Hey, also, like I said, this is our chapter 6 review. For test 5. All right, so this has 20 questions on it. So let's see, number 1 wants us to find the square roots of 4. So remember, on these questions, they first ask us for the principal square root and then the negative square root. So first, we'll find our principal square root. And so remember, y'all remember square root of 4 looks like this. So I'm just looking for a number that multiplies twice to get a 4, and that number would be 2. Then it wants to know the negative square root. So the negative square root, because remember, like signs make a positive. So 2 times 2 makes a positive 4. Also a negative 2, because negative 2 times negative 2, like signs, makes a positive 4. So anytime we look at square roots, remember, it could be 2 positive numbers or 2 negative numbers. All right, so number 2 wants us to find negative square root of 16 over 9. Y'all, no matter what, this answer will be negative because we got a negative in front of this radical. Now, what you got to realize on this one is that the square root affects the top and the bottom number of the fraction. So this would be like a square root of 16 over a square root of 9. So now I would take the square root of both of these. So now I end up with a negative. Square root of 16 would be 4. Square root of 9 would be 3. So the main thing you got to remember is don't forget to bring down that negative. And, this one can be done on the calculator, so I'm going to share that real quick. So first I'd punch my negative. Then I would hit second x squared to get that square root radical. And then I would do 16 divided by 9. So then when I hit enter, remember, it's going to give me a fraction, but if I hit math and enter twice, it'll put that back as a fraction for us. So any of these that's just got numbers on them, we can pretty much do those on our calculator. So number 3 says find the square root that is a real number. And they're giving me a square root of a negative 4. If you want to think about this, remember, a square root's looking for a number times itself that equals what this number is under that radical. Remember, like signs are always positive. So since I got a negative number under that radical, there's no way that I can get a real answer out of that. So on this one, we would put the square root is not a real number. Hey, let me show you what happened on the calculator on that one. So if I try to do the square root, so x squared to get the radical, and then put in a negative 4. When I hit enter, I get a non-real answer. That's telling me that it cannot do this in the real world. Okay. So just remember that we cannot take square roots of negative numbers. Before wants us to simplify. And they're giving me a cube root of 512. So what I'm looking for is a number that multiplies times itself 3 times to equal 512. And this one should be a perfect cube on the test for you, like mine will be. So now one way you can do this is on the calculator. So let me bring up my calculator. So to do a cube root, you would hit the math button and look at option number 4. Option number 4 has a cube root. So punch up cube root and then put in your 512. And when you enter, we should get 8 out of that. Okay, so 8 times 8 is 64. 64 times 8 equals 512. So that answer, we got 8. And remember, you can check these by multiplying that number back. 8 times 8 times 8 will give me 512. All right, y'all, number 5 is another simplify. So this time we're giving me a cube root of a negative 27 x to the third. Now, we are able to take cube roots of negative numbers because a negative times a negative will equal a negative, okay? So you can't do square roots with them, but you can do a cube root. So the thing about this, if you're taking a cube root of a negative number, that answer will be negative. Now for the cube root of negative 27, you could have done that part on the calculator. So let's see. So let me get that cube root by hitting by hitting my math button. And going down to option 4. And then I'll put in my negative 27. So this will find what number times itself 3 times equals negative 27. And y'all, that number will be negative 3. So we know it's going to be a negative 3. Now, when you got exponents on variables, what you do to see how many come out, you take this exponent 3 and divide by that index of the radical. So 3 divided by 3 is 1. So that means I come out with 1x. So if I take negative 3x times negative 3x times a negative 3x and multiplied all 3 of them together, I would get a negative 27 x to the third. All right, y'all, number 6, rewrite without rational exponents. And then it says, if possible, simplify. So they're giving me x to the 1/9. And y'all, this was just to show you how radicals and fractional exponents were related. Just remember, the bottom number of the exponent is the index to the radical. Okay? The top number is the exponent of the variable. So what you're going to do, you're going to make your radical. 9, since that's the bottom number of the fraction, that becomes the index of the radical. So that's going to go right in the little notch where we put the index. Underneath, I would put my x and then my exponent of 1. But y'all, since that's a 1, I technically don't need it there. But remember, it is like a 1 sitting there. So in Math Lab, I would probably just put my 9th root of an x to make sure that I'm in the most simplified form of that, okay? Now, number 7 will be the same thing, but we will actually have to simplify it. So let's see. So y'all, number 7, rewrite without rational exponents. And once again, simplify if possible. So they're giving me 16 to the 3/4. So I'm going to show you another way to do this one. Same thing, I'm going to write it as a radical. The index of the radical will be the bottom number of the fraction, which is a 4. Then I'm going to put my 16 under here. But y'all, then, instead of putting my exponent 3 by the 16, I'm going to put the exponent 3 to the outside of the parentheses. So either way works. But when you got numbers, it's easier to take the roots first and then apply that exponent. So what number times itself 4 times equals 16? And that's got to be a small number, right? So let's think. That'd be what, a 2? Because 2 times 2 is 4, times 2 is 8, times 2 is 16. So the 4th root of 16 would give you a 2, and you still got the 3rd power sitting out there. Now, 2 to the 3rd power, 2 times 2 is 4, 4 times 2 is 8. But y'all watch this, and on the calculator, that's got all that is numbers. So we could do that on the calculator also. So y'all let me clear everything off here. So I had 16 to the 3/4. So I'd punch my 16, then hit my caret for the exponent, and then put in 3 divided by 4. So now I've got 16 to the 3/4. When I hit enter, we get 8, which is what we got doing it by hand. So y'all, either way on those, remember, when you got numbers, it's easier to do the roots first and then apply the exponent, okay? All right, so 8 goes the other way. It wants me to rewrite with a rational exponent. And they're giving me the 4th root of 18. So 18 is your base. So bring out the 18. Now remember, we're going to write it with a rational exponent, which is a fraction. We know automatically that the index of that radical is the bottom number of the exponent. So the 4 goes to the bottom. And y'all, once again, since the 18 don't have an exponent by it, we assume that it is a 1 sitting there. So the top number of my fraction has to be at least a 1 on that, okay? All right, then you started getting into where we had to simplify radicals. So this one says simplify by factoring. So y'all, since we're going to be looking at the square root of 54, over here, I'm going to draw something real quick. And this is called perfect squares. Now, 1 times 1, which is 1, is a perfect square, but it doesn't help me simplifying these. So I'm looking for perfect squares like 4, which is 2 times 2, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and I'll do one more, 169. Perfect squares are numbers that have square roots. Square root of 4 would be 2. Square root of 9 is 3. Square root of 16 is 4, and so on. And I did it all the way up to 169, which has a square root of 13. But when I'm simplifying these radicals, I want to find perfect squares. So I want the largest perfect square that would be a factor of 54. So you can sort of start dividing by these numbers to see what gives you a perfect division that don't give you decimals. So y'all, on this one, 4 is not a factor of 54, but 9 is a factor of 54. And 9 is the largest number over here that would be a factor of 54. So I would make this a 9 and a 6. Because 9 times 6 is 54. But the reason I chose 9 because it's a perfect square, and I can take the square root of the 9. So that the square root of 9 would give me a 3, and then bring down my square root of 6. Now the 6, to make sure I'm done, the 6 does not have any of these numbers as a factor. So that tells me I've simplified it as far as I can go. Now, if you want to remember, if you want to be able to find factors quick, remember, I can show you the trick on the calculator. If you go to this y equals, so let me see, I had 54 was my number. So if I do 54 divided by x, and I just want to go to the table, so I'm going to hit second graph to bring up the table. There's all my factors, 1 and 54, 2 and 27, 3 and 18, but none of those numbers are perfect squares. Then I go to 6 and 9. 9 is the perfect square. And if you keep going through it, there's my 9 and 6 again. You'll notice that everything else is going to give me decimals. So 9 would actually be the largest perfect square factor. So you can use the calculator to sort of help you find factors of their numbers also, okay? All right, number 10, same thing, simplify by factoring. All right, so I'm going to have a square root 1,125 x to the 4th. So I've got part of my perfect list here. Let me go further. So 196, 225. So that'd be 14 times 14, 15 times 15. I'm bringing this one out because I got a 1,125 sitting here, okay? That is a big number. So I'm going to see if that 225 is a factor of 1,125. If it's not, then I'm going to check 25 up here. Okay, since that ends in a 5, it's got to be one of those two numbers. So what I'm going to do is just go to my calculator and see if it'll divide by the 225. So y'all, we had 1,125. Let's see if that divides perfectly by 225. And when I hit enter, I get a 5. So that tells me that 5 times 225 equals that 1125. So I'm going to make two radicals here. I'm going to put my perfect squares over here, which was the 225. And then the 5 goes in the second radical. Okay, now with variables, since this is square roots, even numbers divide by 2. So since that's an even number, I'm going to put everything into the perfect squares. Now, had that been a 3 or a 5, I'd have put 1 over here and the rest over here to make all the even ones, okay? But if these are even exponents, they will come out perfectly. So now we would take the square root of 225. So remember, square root of 225 we said was 15. So that'll give me 15. On the variables, I take the exponent and divide by the index. And y'all got to remember, if there's no numbers there, we treat it like a 2. So 4 divided by 2 means that I get x squared out of that. So it's basically half of whatever these exponents are that comes out. Now, couldn't do nothing with that square root of 5, so I come down and keep my 5 inside the radical. Okay, so that's a trick, just finding factors that are these perfect squares, okay? And if you needed to go further, you could do 16 times 16, see what that equals, and so on. All right, y'all, guess what? Number 11 doing the same thing. So we're going to hit you with a few of these. So number 11, simplify by factoring. So I got a square root of 80 a squared b. All right, so if I was looking at 80 and I was looking at my perfect square factors, I would start dividing by my numbers until I got perfect square roots. Or we could go to the calculator and do that and go through and look at all the factors, and you want the largest factor that's a perfect square out of that. Well, y'all, if you did that, you would get 16 as the largest perfect square times 5. So 16 times 5 is 80, and 16 was the largest perfect square that you'd have found in that list. Now watch what I do with the variables. Since the a has an even exponent, both of those go over here. So I bring out my a squared. Now remember, the b is like it's got a 1 by it. Well, 1, since that's an odd number, that 1b will stay in the right side, because there's no way I can take the square root of a b, okay? All right, y'all, so now this side will stay the same no matter what. What we got to do over here is take the square roots of both of these. So the square root of 16 gives me a 4. Remember, on the variable, I'm going to divide the exponent by the index. 2 divided by 2 gives me 1, so that comes out as 1a. And then I still have a square root of 5b. So if you got an odd exponent, you will have leftovers under that radical, okay? All right, y'all. 12 says multiply and simplify by factoring. All righty. So under my first radical, I got 5b to the third. That's getting multiplied by a 35 c to the fourth. So I'm going to multiply first, and then once I got my single radical, I will then try to do some of this simplifying to it, okay? So 5 times 35 gives you 175. So you got a B3 here. There's no B's over here, so that's going to come down as a B3. And then I got a C4 over here. There's no C's here, so that'll say a C4. All righty, so now I've got my product. I'm going to now simplify that. So if I look through my perfect squares, the largest perfect square factor of 175 would be 25. And if you divided 175 by 25, you get a 7. So this would be 25 and 7. And y'all watch what I do with these B3s. Remember, 3 is not an even number. So what you do when you got an odd exponent, you automatically will put one of the B's over here. So if you take one B away, that's going to leave the other two B's in the first radical. So if that was a 5, I'd put 1 and 4. 7, I'd put 1 and 6, and so on. Now the C4 is an even exponent, so the C4 is all going under the first radical. The only time you're going to have a leftover under the second radical is if you got an odd exponent, okay? All right, y'all, so let's see what happens now. These are all perfect squares, so they're all coming out. Square root of 25 gives me a 5. On the B, 2 divided by 2 leaves me 1, so I come out with 1B. On the C, 4 divided by 2 is 2, so that comes out as a C squared. And then we cannot do anything, so the square root of 7B comes down. Okay, so just remember on these, if it's an odd exponent on a variable, you will have leftovers under that radical. Hey, y'all, number 13 says divide and simplify. So I got a square root of 50 over a square root of 2. All right, so since both these numbers are under the radical, I can actually divide that. So I would take the 50 and divide by 2. Now the answer at this point will stay under that radical. So 50 divided by 2 gives you 25. So I get a square root of 25. And that square root of 25 will simplify because that's a perfect square. And y'all, the square root of 25 will give me a 5. So let me show you on the calculator. You can do this one. I'm going to clear my screens real quick. So I could do second x squared and put me a 25 in there. Arrow out from the radical and put my divide. And then do the second square root and put in my, whoops, my numbers are wrong. That was a 50, so let me make that a 50. And then over here I had a square root of, I'm dividing by what? Square root of 2. So I got my square root of 50 divided by square root of 2. Now notice it'll give me my final answer of 5. Now if you want it to look like a fraction, you can hit alpha y equals and hit enter for ND. And you can do the same thing here. Second x squared, put in your 50. Then go down to the bottom. Second x squared, put in your 2. All right, and if you do that way, you still get a 5 on that. So if you notice, a lot of this test is mainly doing that simplifying, okay? All right, y'all. So number 14 says add and simplify. Okay, so they're giving me 2 square root of 5 plus 7 square root of 5. So remember, in order to add these, the radicals have to match up. The square root of 5 has to match this square root of 5. Since my radicals match up, I can now add the numbers in front and then bring down that radical. So the radical part will stay the same. All we can change is the numbers in front. So what I would do is add my 2 plus 7, get me a 9, and then bring down my square root of 5. So we don't change the radical, and that's sort of like the like denominators on these, or the like terms. All we can change is how many we got, okay? Now let's do one a little more challenging, and be this one where we subtract. So we're going to subtract and simplify. So y'all, they're giving me a 7 square root of 27 plus a 7 square root of 5. As it looks, whoops, hang on, that's a 3 right here. So y'all, let me change this. 7 square root of 27 plus a 7 square root of 3. All right, so make sure you change that. Now, at the moment, I cannot. Oh, I'm messing up big time. This is subtraction also. All right, so let me write it for the third time. 7 square root of 27 minus 7 square root of 3. All right, because remember, it is subtraction. So I cannot subtract or add when the radicals don't match up. So I've got to try to see if I can rewrite one of these to match the other one. Now, y'all, there's nothing I can do with that square root of 3. But I'm going to play with this square root of 27 and see what that'll do. So on the side here, I'm going to try to simplify 7 square root of 27. And I'm really focusing on that radical. And I'm looking through my perfect squares that I gave y'all to see what the largest factor of 27 is. So bring this 7 down and make that 27 into 2 radicals. If you go through the numbers of perfect squares, you'll find the largest perfect square factor of 27 would be 9. That puts a 3 in the other radical. And y'all use this one to guide you. If this one's a square root of 3, if I'm going to subtract these eventually, I'm going to need a 3 under that other radical, okay? So now what we do, we bring this 7 down. It's going to multiply by whatever the square root of 9 is. So y'all, the square root of 9 would be 3. And then bring down that square root of 3. All right, so now let's multiply these and get our final simplification before we put it over here. So 7 times 3 will give you 21 square root of 3s. So I can now replace this with my 21 square root of 3 minus my 7 square root of 3. So your whole goal is to make this one look like that one, which we did. We got square root of 3s now. So remember, since the radicals match, I subtract the numbers in front and then bring down my radical. So it's 21 minus 7 is going to give us 14 square root of 3s. So just like adding, when you add, the radical don't change. When you subtract, the radical does not change. So y'all just remember, on your number 15, you'll have to simplify one of your radicals to make them match up. Alrighty, y'all. Then we got into multiplying. Well, this one says multiply. So we're given a square root of 3 minus a square root of 8 times a square root of 3 plus a square root of 8. Now, the thing you got to remember, these are what we called conjugate pairs. Remember when we was foiling conjugate pairs? You ended up with single numbers and stuff like that. Well, when you multiply conjugate pairs of radicals like this, we're going to end up with a single number on this, okay? So here we go. Now remember, when you multiply radicals, insides multiply by insides. If we had numbers on the outside, they would multiply by only on numbers on the outside. But since all these are inside, we can multiply all these together. So watch this. First, I'll start with square root of 3 times square root of 3. That's going to give me a square root of 9. Then I'll do the square root of 3 times a positive square root of 8. That's going to give me a positive square root of 24. So 3 times 8 was 24. Now the next one's going to be negative because you got a negative times a positive. So we know it's going to be a negative. So a negative square root of 8 times square root of 3 gives me a negative square root of 24. And then at the end, I got a negative times a positive. So that's going to be a negative. Square root of 8 times square root of 8 is the square root of 64. Now you'll notice when you multiply these conjugate pairs like this, notice these two in the middle, square root of 24 minus the square root of 24, that's going to cancel. So the middles will always cancel. So now we figure out what the square root of 9 is. Well, y'all, the square root of 9 is 3. And then at the end, you got this minus square root of 64. So that's going to be minus. And the square root of 64 is 8. So this gives me 3 minus 8, which ends up being a -5. But y'all watch this. When it's got all numbers like this, our calculator will knock that out quick. So let me start my parentheses. So I had a square root of 3. So second x squared, put me a 3 in there. Arrow out of that radical. And then I had minus square root of 8. So second x squared, put in my 8. Arrow out of that radical, close parentheses. Then I do my parentheses again. And I had a square root of 3. Arrow out of the radical. And then this one was plus a square root of 8. Arrow out of that radical and close parentheses. And y'all, what we should get is what? A -5 on that. So when I hit enter, I get my -5. So they're not bad. Just remember on these that you're going to get a single number when you got conjugate pairs, okay? All right, y'all. So let me try number. That was what, 16. All right, 17. Rationalize the denominator. I got a square root of 11 over 2. Now, y'all remember, this is like a square root of 11 over a square root of 2. So what we mean by rationalize the denominator is that the denominator of a fraction cannot have a radical in it. So to rationalize this, we multiply the top and bottom of the fraction by the radical in the bottom. So since I want to get rid of the radical on the 2, I'm going to multiply top and bottom by a square root of 2. All right, so let's see what that does. Square root of 11 times square root of 2. 2 times 11, that's going to give me a square root of 22 over 2 times 2 is 4. So that gives me a square root of 4 on the bottom. So now it's time to simplify this. 22, if you look through them perfect squares, none of those perfect squares are a factor of 22, so I cannot do nothing to the square root of 22. But y'all, we know the square root of 4 because 4 is a perfect square. And the square root of 4 will give us a 2. Now, the thing you got to watch out for, this does not simplify any further because, see, the 22 is under a radical. You can't divide numbers under a radical by numbers that are not under a radical. So that would be our final answer. And we accomplished the goal because there is no longer a radical in the bottom of that fraction. And y'all, I'll tell you, the last 3 are solved. So the first one, solve a square root of x plus 3 equals -3. So the first goal is to get this radical by itself on one side or the other. And this radical is by itself. Because remember, the x plus 3 is under that radical. So the radical is by itself. So the next step would be to get rid of this radical. So to get rid of this radical, you're going to do what we call square each side. So we're going to take the square root of x plus 3 and square it. We're going to take this -3 and square it. So to get rid of radicals, whatever the index is what exponent you raise these to, okay? So what happens when you square a square root, the radical cancels. All that's left is the x plus 3. So the exponent of 2 cancels out that radical, okay? Now, on the right side, you got a -3 and you're squaring it. Remember, negative times negative is a positive. So -3 times -3 gives you a +9. All right, y'all. Now to finish solving this, to get this x by itself, all I got to do is subtract 3 from both sides. So I get my x, those cancel. And on the right side, 9 minus 3 gives me a 6. So I'll put the 6 in here. 6 plus 3 is 9. Square root of 9 equals -3 is true. Remember, 9 has a positive square root and a negative square root. Okay. Oh, y'all, so that's the trick on that. Get the radical by itself, raise it to whatever exponent matches the index. So let's solve a cube root. We got the cube root of 3x plus 6 plus a 6 is going to equal 8. So notice this plus 6 right here is not under the radical, so I need to get it moved to the other side. I want this radical here all by itself. So since that 6 is being added, we're going to subtract a 6 from both sides. So that brings down our cube root of our 3x plus 6. That's going to equal, because those cancel now. And then 8 minus 6 leaves me a 2. So now we got the radical left over here by itself equal to a number. So now we're going to cube each side. Since that's an index of a 3, we're going to raise both sides to the third power, which is called cubing it. So I'm going to come in here and cube both sides. So notice, the cube root and the cube, they cancel each other out. All that's left is 3x plus 6. And over here, 2 to the third power, 2 times 2 is 4. 4 times 2 is 8. All right, y'all, solve this for the x by subtracting 6 from both sides first. So notice I get my 3x, those cancel. 8 minus 6 gives me 2. Remember, 3x needs to be 1x, so divide both sides by 3. So those cancels, making that a 1x. And that's going to equal 2/3. So if you put the 2/3 in here, the 3's cancel. 2 plus 6 is 8. Cube root of 8 is a 2. So y'all are not too bad. You just got to try to get these radicals by themselves so you can get rid of them by cubing them or squaring them or whatever you got to do, okay? All right, y'all. Then we had one, number 20. Now, this one's intimidating, but it's probably one of my favorites on here. It says solve. On one side, they got a square root of 5y plus 2. Y'all, that's going to equal the other side, which is a square root of 4y plus 6. Now, I like it when there's a radical equal to a radical if all the numbers are under the radicals. So this radical is by itself on that side. This radical is by itself on that side. So what we're going to do is square each side. Because there's nothing I can move because everything's under this radical and everything on this side's under that radical. So we're just going to square each side. Guess what? When you square each side, when you square this side, it's going to cancel that square root. So all that's left is the 5y plus 2. Well, on the right side, when I square it, it's going to cancel that radical out. So all that's left is the 4y plus 6. Okay. Now, in college algebra, we up the ante a little bit by maybe adding other numbers here. But on this test, when you got a radical equal a radical, square each side, and you'll get what was under the radical equal to what was under the radical. So I'm going to try to get all the y's over here. So I'm going to subtract this 4y from both sides. So y'all, if you do that, 5 minus 4 leaves you 1y plus 2. Over here, the y's cancel. All that's left is my positive 6. Now, to get the y by itself, I'm going to subtract 2 from both sides. If I get my y, those 2's cancel, and then 6 minus 2 is 4. So let's see, if I put a 4 in here, 5 times 4 is 20, plus 2, that gives me a square root of 22. If I put my 4 over here, 4 times 4 is 16, plus 6 gives me a square root of 22. So that will check out. And y'all, that is our test 5. So now this will be the last chapter test we have. After this test, the only other test we'll have is the final exam. Now we'll go over material on Thursday. Dealing with the imaginary numbers and doing the quadratic formula. After that, all that's left is this final exam, and we'll probably review for the final exam next Tuesday, okay? And then if I need to do more review, we'll do it next Thursday. But remember, next Thursday, everything's going to be due for this class, okay? Because that'll be August the 4th, which is our last day of class, okay? All right, I'm going to stop my share. All right, y'all. So, any questions y'all need to chat me? All right, so I'm not saying nothing on my chat. So y'all remember, email me if you got any issues. Good luck on my test, and I will see y'all, looks like, on Thursday night.